You're listening to MedX, the Medical Extrusion Podcast. Presented by U.S. Extruders. Extrude with confidence. Custom extrusion equipment designed for you and your application.
Welcome to the MedX Podcast. I'm Steve Maxson. Today's discussion is focused on transforming extrusion from an art to a science. Our guest is Braulio Polanco, founder and CEO of Systematic Extrusion. Systematic Extrusion provides hands-on extrusion process training focused on the medical device industry. They have developed a data-driven approach based on scientific principles for extruding tight tolerance medical tubing while simplifying the validation and manufacturing process. Braulio, thanks for joining the MedX Podcast.
Thanks, Steve, for the invitation, and thanks for the great introduction. I look forward to this discussion.
Excellent. Braulio, tell our listeners the story behind Systematic Extrusion and the services that you provide.
Certainly, yeah. Our mission really is to transform extrusion from art to science. Many years ago, Systematic Extrusion was formed because we noticed that there was a lack of inconsistency on how you develop the extrusion process. But more importantly, there was a lack of scientific principles that would be used as an approach to develop the process. Many companies today, as you know, Steve, rely on highly experienced operators, technicians, or engineers to be able to develop the process, but they tend to be a very, I would say, trial and error approach. So as a result, these operators are very difficult to find in the industry, and so developing a method that is consistent from time to time, it's very difficult.
Yeah, from my experience, contract manufacturers, medical device OEMs, one of their biggest challenges as it relates to extrusion is finding talent, technicians, process engineers. It's a real challenge. It's a challenge across the board, but we live in the extrusion world, so we see it more directly.
Certainly. So, Steve, this has allowed us an opportunity to develop a scientific approach that will transform extrusion from art to science. The basis of our method is based on the understanding of how polymer thermal and flow behaviors are generated to understand the temperature viscosity at which the resin should be run. So what we do up front, even way before we run an extrusion operation, is we do a lot of thermal and mechanical testing, what we call polymer characterization testing. Mm-hmm. And we do that to understand at what temperature and what viscosity we want to run. And the key to our approach is really running the material to the same viscosity all the time. When that happens, we can have consistent inputs that can predict what the outputs would be. And so we do a lot of testing up front, such as DSC, TGA, and rheology, to be able to understand those thermal and mechanical behaviors of the polymer.
Braulio, when you talk about transforming extrusion from an art to a science, let's face it, in medical extrusion at least, that's a tough crowd, right? Not everybody probably buys into this concept. Tell us a little bit about maybe some of the pushback that you've received related to this concept and how you've handled it.
Certainly, Steve. Yeah, this is one of the biggest challenges that we have when we try to push our course and our methodology. In fact, we have an interesting slide that we show during the course where we call those individuals the dinosaurs. And we have a great friend of ours who drew a picture of this dinosaur predicting how, they're the most knowledgeable senior people, but they need to figure out how to adjust. And this dinosaur, it has a meteor that's coming from the top that is basically kind of like our course. And they need to either get on board or jump off the boat. That is the biggest challenge we have. It is very difficult to convince people that have been doing this for 20, 30 years on how to do something different, a different method, right? That's based on science. It's not that they're approach doesn't work. It's just that it may take longer, right? So it's a very iterative trial and error approach where we have a way that you can consistently do it, whether you have 10 or 15 years of experience. But one of the good things about our course is that not only is it learning the theory, but we also have a portion of it that it's a hands-on portion that proves that our theory works. So I think when individuals with many years of experience go through that phase where they learn, the theory, but also see the proof on how it works on an extrusion, that's what makes them believers.
The data, right? It's all about the data.
It's all about the data. Data's king.
Exactly. Thank you. So the testing that you do, if you think of a reflow catheter, a common reflow catheter that has variable durometers, starting maybe with nylon and P-backs going from 72D down to lower durometer, maybe even a soft TPU on the tip. Those are the common materials used on a reflow catheter. Do you still need to go through that testing process for those common materials?
So what we recommend is every material is going to have its own thermal characteristics, right? However, there are materials that are very similar. So durometer, for instance, and P-backs, they don't really change much the thermal characteristics, but the molecular weight will significantly impact the mechanical or flow behavior of the material. So if you don't have that knowledge of that information, being able to generate a rheology curve for each of those different durometers is highly important because they will dictate at what temperature you should be running your material to be able to match the viscosity from lot to lot. So that's another big advantage of our systematic approach looking at rheology data is that, as you know, for instance, many other suppliers rely on the melt index as a data point for determining how the material flows. However, that it's only one point in an entire viscosity curve. Yep. With our approach, we look at the entire curve and then we decide where in that curve do we want to run the process, where it gives you the less variation between lot and lot to lot.
Excellent. Okay. Braulio, when you think of the different phases of a medical device development to commercialization, prototyping, optimization, verification, validation, design transfer, commercialization. In the context of extrusions related to a medical device, a sheath, a catheter, a delivery system, walk us through this data-driven approach that could potentially allow contract manufacturers, medical device OEMs to have a competitive advantage when they're bringing devices to market.
Certainly. That's a great question, Steve. And one of the big benefits of having this data approach is the fact that you have a system that you follow. And it doesn't really matter whether you're an operator that started, a couple of months ago, or if you're somebody that's been in the industry for, 20, 30 years. So with this approach, you can actually develop procedures to follow on how to develop the process. Another big aspect is kind of we alluded to is that it removes the experience level need for how to develop a process. But more importantly, what correlates to output is being able to run a resin with the same viscosity all the time also removes that lot to lot variation that we normally see. And many people don't know how to count when they get a material with varying molecular weight. How do they account for that in their process so that they're able to make consistent product within the validated range that they've already validated? In addition to that, when we develop a scientific approach, extrusion has many parameters that are key, but there are some that are more important than others and some that can be locked. With our approach, what we do is we define what are the key process parameters, lock the ones that don't require to have a range, and with that, it simplifies the validation process. So what we claim when we talk about scientific extrusion is that you can actually control your entire process with only two parameters. And that enables to have a very simple validation approach, because now you only have to worry about 2 key parameters instead of 5 or 6 or 7 parameters that you would have to do a DOE on, which becomes more complex.
Excellent. Braulio, you and I could talk for hours about medical extrusion, but we have jobs to do, and I think that was great information for our listeners, and we'll leave it there, but we'll try to have you back on another time. Thank you so much.
Thanks for the invitation, Steve. Look forward to it.
All right, bye-bye.
Thank you for listening to MEDEX, the Medical Extrusion Podcast, presented by US Extruders. Please subscribe to make sure you're getting the latest episodes. All links are available in the show notes.